cracking?
No.
Any idea about cracking?
No, sir.
If you talk about the cracking, this cracking, no problem. Cracking means what? Breakdown. This is also called pyrolysis. Pyrolysis. Okay, pyrolysis. Or you can say breakdown. No, breakdown means breaking. We are breaking. Breaking. Or one more word is there. Fragments. These all things are the same. Means what they are saying, that is higher hydrocarbon are there, na? Higher larger hydrocarbon, that they are saying large hydrocarbon molecule can be broken down into a smaller one. That is what is called by process, that is cracking. So cracking is what? Something that is large hydrocarbon you are splitting into what? That is broken down. That is a small one. Suppose if I am having C6 and H, we are having 6 to the 12 plus 2, that is 14. Now you can split into many hydrocarbon form. What we can do, that is C4H8 and that is CH4. No, C2, that is 4 to the 8. C2 is left, and how many hydrogen? 4. C2H4. So this is the two hydrocarbon. We split the one hydrocarbon into the two part. Similarly, we can take into the C2H6, C2H4, and here all we cannot use here all together. Okay, let us see. C2H6 is there. Then again you can take C2H4 plus, how many left here? C2 and H4. It cannot be. Means that is all together we have to split out. If I am taking C3, 3 to the 6, H8. So this is also, see, this is what the both are the alkene molecule. Smaller alkene they break out, and here is one alkane and one alkene. This is what the resultant, how it is going to split out. Can you see this one? So here you can see the process takes place at oil refinery in a steel vessel called the crackers. In the crackers, a heavy fractional distillation from the crude oil is heated to evaporate the hydrocarbon. So when you are heating the hydrocarbon, it is going to be evaporate in the small molecules. They are making the small molecule. I'm not going in the much detail. Just I'm taking you the example. I'm telling you. Here, see the example of alkane. What is their decane? What is the formula of decane? Dec means the 10 carbon. So dec means 10 carbon means C10, and it is going to be 22. C10H22. So here decane is there. If you are heating at 500 degrees Celsius in presence of catalyst, see it is breaking into the three part. Can you see? Hello?
Yes, sir.
So can you understand what is the meaning of the cracking? That is splitting into the broken down into the smaller part. Where you are doing in oil refinery, huge crackers like this are used to break down the large hydrocarbon molecule into a smaller one. So this is what the simple definition of the cracking is there. Next one, the important point which I am supposed to teach you.
Sir, can
This
you
one.
just scroll up for a little bit?
What?
Can you scroll up for a little bit so I can write down the definition?
Okay.
No, I want to write the definition.
Cracking definition. Here the definition.
Yeah.
Acha, let me. Can I write here cracking definition?
Sir, book में है नीचे.
Already done. Here.
Oh yeah, there.
Large hydrocarbon molecule can be broken down into a smaller molecule. The process is called cracking.
It's broken down
Into smaller molecules.
smaller molecules. And then it takes place.
It takes place where it takes place. Here it takes place in the still. Here where is the word? Here you see the next paragraph. Here is the oil refinery. What is the? It takes place at oil refinery in steel vessel called crackers. These are there. If you read the total statement, not required to read out, you can read also. If we read this statement now, you can easily understand. See what they are saying. In crackers means what is called, that is steel vessels, a heavy fractional distillation distilled from the crude oil. Crude oil means, that is what is the crude oil? Do you know what is the meaning of crude oil?
Yeah, it's the fossil fuel uh
Yes.
that's like comes out from the earth, and then we use it to make like generate electricity or get petrol and stuff.
That's okay. So crude oil means, basically crude oil means, that is what is extracted, unrefined one. Because what they are extracting from the ocean, Gulf countries, they are the crude oil. Okay. And then it is going for the process of refinery. Okay. Crude oil contain only not petrol, not diesel. They contain so many things. Okay. So many things are there. Gasolines are there. Petrol are there. Diesels are there. They are having different boiling points. So they split up into the different parts. Here they are saying, in the crackers, a heavy fraction distilled from crude oil is heated into vaporized the hydrocarbon. The vapor is then either passed over the hot catalyst or mixed with the steam and heated to a heavy high temperature. The hydrocarbon are cracked as a thermal decomposition reaction takes place. The large molecule is split apart from the smaller, more useful one. So they are saying, if they are splitting into the smaller one, suppose this decane is, so pentane, propane, and ethene, they are more useful compared to the large molecule. That is what the example. You just no need to write it. Just you listen. That can be the much better. Here you can see the steel plant is there, this one. What they do here, whatever this container you can see now, this container, here also one more containers are there. These are the steel container. What they are, they are having what type of, that is called the raw petrol, or you can say, this is the another term they are using, crude oil. Here what you are taking, that is crude oil. And crude oil, when you are heating here, so what it is going to convert, it is going to break into the smaller. And here, that is somewhere in this process here, you are extracting at the different level. This where they are, the distillation flasks are there in the different level. You are going to extract, that is different component. How can you extract the different component? Because the oil is having different boiling point. The lesser low boiling point here, suppose a low boiling point, things will evaporate at the top and high boiling point will be at the bottom. So this is what is the cracking process. So let us try to understand some other things here. Whatever the important things are there, that we are going, the other molecule in the reaction have name end slightly differently than end is ene. This type of molecule is called alkene. The different ending tell us these molecules are unsaturated. Unsaturated compound contain at least one double bond between their carbon-carbon atom. Look like, you can see these alkenes have the carbon-carbon double bond, covalent bond, and have the general formula CnH2n. So first one here, Tarni, when they are breaking out, so what they are forming in, here you can say alkane in. Second one, what is there? In. So two things are going to form, alkane and alkene. Notice that this cracking reaction produce different type of molecule. One of these
So,
molecule.
sir,
Hmm, yes.
so cracking में you get,
Hmm.
so in cracking I will have one molecule of alkane and another one of alkene,
No,
or
the hmm.
or
See,
if it's
hmm.
Or if it's alkane, then it will only alkane will be produced. I can't have alkene or alkyne.
No, this is the simple is the lower hydrocarbon. Lower hydrocarbon means less carbon. Less
That is
carbon.
alkane.
Less carbon. And it can be what? It can be alkane and alkene. Both things will be there. Alkane, alkene. Sometime you will find the alkynes also. Here in your syllabus, it is not there alkyne. It is alkane and alkenes are there. Only alkane and alkenes are there. But the definition is what is? Definition is lower hydrocarbon. There is nothing. Some are the alkane. Here you can read. The first part, its name tell us that is it has 5 carbon atom pent. The last part that is ane shows that the alkane. Like all other alkanes, pentane is saturated hydrocarbon. Its molecules have much hydrogen as compared, no, hydrogen as possible in them. So maximum is there alkane. So they are saying alkane, alkene, anything is possible. The
No,
condition is what
sir,
it can.
but
Hmm,
my question is, see,
hmm,
if I break down decane, right? Will I
hmm.
only have products those are alkane, or can I have alkane plus alkene as my products?
Both.
So in decane, I can have petane, propene, and ethene.
Hmm, hmm, hmm.
It has both ene, ane.
Yes,
Okay.
yes. But one is having the high boiling point. Here, the high boiling point, right? This is high boiling point, and they are relatively low boiling point, something low boiling point. So what we can do, when you are in the distillation here if you are sending now, so one will vaporize first and then later on fractional distillation. You know now fractional distillation.
Yes.
Hmm. I don't know. It is the teaching in this way. Little maybe you may not be finding much better. Acha, let us go the check out the one practical is there here. Practical. Okay. What they have done in this experiment. Can we do this one? They are saying
Yes.
medicinal paraffin is a mixture of hydrocarbon molecule. You can crack it by heating it and passing the vapors over the hot pieces of broken pot. The broken pot act as a catalyst. So here that is the catalyst are there, broken part, the hit pot. Why must you remove the end of the delivery tube from the water before you stop heating? Right. So first question they are asking that you explain why you must remove end of the delivery tube. This is the delivery tube are there, na? End of the delivery tube. They are saying end of delivery tube from the water you need to remove before you stop heating. Why we should remove? That is what the question is, my. If you carry out this practical, collect at least 2 test tube of the gas required. They are saying taste the gas another unsaturated hydrocarbon by cracking it with the few drop of bromine water harmful. React your observation and conclusion. Avoid cold water being sucked back, okay, into the hot tube by removing the delivery tube from the water. Throw before you stop heating. Wear eye protection. Some case collect may be harmful, even toxic. Now, this experiment is there. Here, what is there? Paraffin are there. Paraffin are that is long chain hydrocarbon. Chain hydrocarbon. That is what is paraffin hydrocarbon. You know, na statues are many personalities are being made. You know, so that is made up of what? That is the paraffin wax only. Like the I think the most of the people in the London somewhere they keep the statue of the personalities, or even in the some
Madame
museum
Tussauds.
also. Hmm. So that is made up of what? Paraffin wax only. Now if you are hitting this one paraffin wax, so what two things you are going to get? You are going to get alkane, and secondly you are going to get the alkene. Now they are saying firstly you are removing. Why you are removing? If you are not removing this cap, so what will happen? It will absorb the water molecule, and water will go this side backward. That is why they are saying that is we have to remove back. Now the second portion what we are going here, that is alkane and alkene are being formed. Here they are saying by shaking it with few drop of bromine water. So what we are going to do here, you see, suppose alkene is forming na C double bond C. Okay, here is suppose H2 are there, whatever. And if you are adding the bromine, so what is bromine is color. Bromine is color, right? So it will give that is Br CH2 and then CH2 and here is Br. And this molecule is colorless, colorless. So one thing is there, that is you need to firstly alkane will form, there is no doubt about it. Okay, when you are splitting the higher hydrocarbon, alkane will form, surely low alkane will form, but on the same time alkene is also going to be formed. How can you take, how can you check? You add the bromine water. Here you are adding the what? Bromine. And bromine is the color world, dark color, it is the bottle, you will find the dark color bottle bromine. When you are adding this bromine into the test tube, the color will be colorless. So that is what you are going to get, that is alkane and alkene. With this experiment, you can be able to understand the alkane and alkene both are making form. Can you understand this one?
Yes, sir.
Hmm. So now, here you see, making ethanol from ethene. Okay. So ethanol from ethene, how can you make here? Because there is no blank pages at all. So where should I write? So do you know that is the formula of, you tell me ethene formula. Can you tell me the formula of ethene?
Ethene, ENE?
Hmm.
I think ENE's formula is CN plus
Hmm.
H CN plus H2N. Ethane
Okay.
has two
Hmm.
methane,
Hmm.
ethane, so C2 plus
Hmm.
H4.
Okay. Thank you very much. Thank you very much. Okay. So that is, you told me that is ethene. Ethene. So ethene, this is ENE. So formula you are saying that is CnH2n. Eighth means you told that is eighth means that is number of carbon n is equal to 2. So that is in this formula, if you are putting 2 value, so C2H2 into 2. So it is going to be C2H4. And here if you are making the structure CH2 double bond CH2, we are supposed to prepare the, what we are going to prepare, that is alcohol. Okay. So alcohol from ethene. This is what you are talking. Alcohol from alkene. This is what the topic is. So here you see, Tarini, you treat with the water molecule HOH. Can we write the water molecule H2O as HOH? Can we write water molecule as HOH or
Yes.
not? Okay. So if you are writing water molecule as HOH, so with one carbon, it is going to add. With one carbon, hydrogen is going to add. Is going to add. With the other carbon, it is going to be add what? OH. So what it is going to be, that is it is CH3, CH2 and OH. Okay. This is what is called 1, 2. 2 carbon is H, single bond is N and OH group is all. So this is the ethene, and that is you are preparing ethene to ethanol. This is the method. What other things you use in this reaction, that is called concentrated H2SO4. Concentrated H2SO4 required. So how you can prepare the alcohol from ethene? That is when you are treating the ethene with what? Water molecule. Then it is going to give what? Ethanol. Can you understand this one?
Not really, it's
Hello?
confusing. So,
Acha. Okay. Wait. CH2 double bond CH2. Can you tell me it is ethene or not? Is it ethene?
no.
Why no? 2 carbon is eth,
Oh, yeah, yeah,
double
because
bond
it's
is
double
in.
bond.
Treat with the water molecule. Can we write the water molecule like that, HOH? H2O. Can you write like that?
But why would we write it like
Yes,
that?
yeah, no.
Why
I
would we
just
write it
want to
like that?
explain you the reaction. I just want to explain the equation. Na. Alcohol, what is the group of alcohol? Which group is there? Functional group, alcohol group. Can you tell me formula? OH group. Can't you understand? Alcohol is having OH group. Yes, yeah, no.
Yes.
What is the group of aldehyde?
I don't know.
CHO. Carboxylic acid. Can you tell me carboxylic acid?
Carbon.
What is group carbo? COOH. Yes, yeah, no.
Okay.
Okay. So what is going to happen with one carbon? It is going to H, another carbon it is going to. So what is it going to form? That is CH3 and CH2, and here is OH. Right? And carbon valency is 4, here is single bond. Double bond converted into single bond. OH group, what the word use? We use OL, all. Right? So 1, 2. 2 carbon is what is that is going to H, single bond is N, and OH group is there, ethanol. Can you see? No.
Yes.
But I think you are not able to know the name of ethanol and these things. Okay, come back to your page. Better you can understand here. Okay, what the question is there here, you can see. Question, you are having the heading, making ethanol from ethene, and that is called hydration. What is hydration, Tarini? If I will ask you hydration. Hydration means what? Addition of water. Hydration means, if I will write definition, hydration means what? Addition of water. Addition of water. That is called. Now see, ethanol from industrial use as a fuel or solvent can be made from ethene gas instead of the fermentation. Ethene is main byproduct made in cracking. This is where you are making cracking of ethene gas can react with steam to make ethanol. So this is the water, steam, and this is ethene. What it is forming? Ethanol. Can you understand this one?
Yes.
Yes, Tarni.
Yes, sir.
Sure, na?
Yes.
Okay, very good, very good. Acha, now we come up to the some questions. Okay, now read out the summary questions. Question number 1. Can you read the
Why
summary
is
question, Tarini?
why is cracking so important?
Ah,
Cracking is important as it splits smaller large molecules into smaller particles
mm, mm.
without
And
with
smaller
like
molecules are more useful, Tarini. Smaller molecules are more useful compared to large molecule. Got it?
yes.
No. Acha, okay. I am telling you the answers.
No,
Where
I
is the
said
answer?
yeah.
Why? Just I want to tell you the answer is there here. More, where is the more useful? You can read out the terms. That is, when you are splitting, the hydrocarbon are cracked as thermal decomposition reaction takes place. The larger molecule is split apart from smaller, more useful one. Which one is more useful? A smaller one or larger one?
Smaller.
A smaller one. So that is what the person they are saying, Tarini, here. That is why cracking is so important, because we are splitting the larger molecule into smaller molecule to get more useful one, right? Next question. Read out the next question, please.
How can large hydrocarbon molecules be cracked in an oil refinery? So in an
Yeah,
oil refinery, they're placed in a steel vessel called crackers, and those crackers are So those crackers are heated, and so when the molecule is vaporized, they add steam to it or a catalyst. That catalyst speeds up its reaction to time, and because it's already in steam and is heated, it goes to another vessel where it is cooled down, and the products are broken down.
Okay, you explain much better way. Next one, question number 2. Cracking a hydrocarbon makes two new hydrocarbon, A and B. When bromine water is added to A, nothing happens. But bromine water added to B turn orange solution to colorless. Right? Now the answer one. Which hydrocarbon A or B is unsaturated? Tell me.
I think bromine added to A turns orange. Solution to colorless. Nothing happens. When nothing happens, I think A is saturated and double
Hmm.
bonds unsaturated.
So unsaturated is
B.
B. See, if you are treating Tarini, which one? Suppose you are having alkane plus bromine. Okay, bromine. It is no reaction, right? No reaction. Why? Why no reaction? Because it is the saturated. But where you are having unsaturated, if you are having unsaturated, or you are saying or, that is we are saying alkene, and what you are adding here,
Al-
Br2. So that is what is colorless. So whatever the color, it is the something having orange color, and it will become into the colorless. Can you understand this one? So
Sure,
yes,
one
Tani
second.
understood.
Can I write that?
Yeah, you can write it now.
Alkene.
Alkane. First one is alkane. Alkanes
Alkene
are
plus
saturated now.
bromine to, yeah, no reaction.
Hmm.
And this is saturated.
Hmm.
And then we have alkene plus
Hmm.
Br2,
Hmm.
which is orange. It's unsaturated, which gives us colorless. Okay.
Done.
Yes, sir.
I explained this one here now. Here, see, I explained this somewhere. I wrote here. You see, this is the alkene
Yes.
treated with the bromine. This is the product, but colorless. So that is you understood much better way. Question number second. You read out this one. Question number second. Can you read second one?
Second one, what do you call the type of unsaturated hydrocarbon formed in cracking? So I don't know.
That is third one. Second one.
Oh, what is an unsaturated hydrocarbon?
Hmm.
Unsaturated hydrocarbon is a carbon at a hydrocarbon which has double bonds of hydrogen.
Okay, thank you. Double bonds. Okay, double bond between two carbon. Okay, this you know. Na third one also you know. What do you call type of unsaturated hydrocarbon formed in cracking? So unsaturated. See, two types of hydrocarbon form. Na somewhere we study two types of hydrocarbon form. See, what are these hydrocarbon? When you are the that is large hydrocarbon are there. Large hydrocarbon. So large hydrocarbon you split, that is you cracking. So that is less carbon compound you got. And less carbon compound is having what? Alkane and alkenes. Yes or no? Alkane and
Yes.
alkenes. alkanes are that is saturated, and alkenes are what is that is called unsaturated. Yes, yeah, no, unsaturated. So question is asking what type of unsaturated, that is alkene or alkynes, what type of compound is going to be formed in caking? Can you tell me? Alkene or alkyne? What type
Mm,
of unsaturated? Yes.
both
Hmm?
both are formed.
No, generally it is going to be alkenes. Up to your book it is the alkenes are there. In our syllabus it is alkynes are also there, but alkynes are rare. So that is, what do you call the type of
Oh,
unsaturated this is alkenes, yes, yeah, no, double bonded,
yes. I
not
misunderstood the question. I didn't understand it before.
now okay na.
Yeah, alkenes are
Alkenes.
unsaturated. Yeah.
Okay, B1, you read the B1.
What hydrocarbon A or B is used as fuel? I think as fuel it
Hmm.
should be A because there is no reaction and as fuel we need less reactants.
Hmm.
I think it should be A.
Okay, let us go back. Okay, and we can read this one little bit. I'm taking your times here to make it clear, right?
Hmm. Yes.
See, here, you read this statement now. Can you read
A
this?
simple
This
experiment like a simple experiment like the one on the next page shows us that alkenes burn, but not as well as equivalent small alkanes, which are used as fuels. Alkenes also react with bromine water, orange in color, which is orange in color. The product of this reaction are colorless. So this gives you a good test to see if a compound contains CC double bond. Positive test for an unsaturated hydrocarbon is an orange bromine water turns colorless.
okay.
Um,
Hmm.
it says that yeah,
Read
small
this one.
alkanes are formed as fuels.
Now go back to the questions here.
So then I would say it's a
Huh. So which hydrocarbon used as a fuel? That is the answer is A.
A.
So you are super duper. है ना? Now
Mhm.
second one.
What do you call the type of saturated alkane?
What do you call type of saturated hydrocarbon formed in cracking? That is alkane. Okay, super. C1.
What type of reaction is cracking an example of? I
Hmm.
think it distillation or hydration.
Okay. That you reply well only, but you go back and you find your own answer. Here, you read this one.
There isn't thermal decomposition.
So decomposition means splitting into the more than two parts. Yes or no? The reaction. This is what? This is splitting. Temperature means thermal. 500 degrees Celsius you read. So decomposition means is splitting into more than one two parts. So if you are splitting into the more than two part, so this is what is that is a decomposition, right? So this is what is student. The reaction is example of thermal decomposition. Can you understand this one?
Yes, sir.
Okay. Next one, question number third.
An alkene molecule is with one double bond containing how many hydro? Okay, so it's an alkene, which means it is Cn plus H2, and we've given that carbon atoms are 12, which means hydrogen should be 24. So C12H24. For 12, I think it is uh the name for 12 is Oh, I know this, sir. It's one
How many?
second.
They are not asking the name.
But
Write
I
down
want to
formula.
give the name.
Okay. Please, please.
It's Dodak
Okay.
and then in.
Do deck in. This one.
Yeah.
Good. Okay. If suppose it is C11, then what you will write?
C11 Undak in.
Okay. Undeck in. So very good. Question number 4.
It's cited over there. Oh my God. I didn't have to look through my notes.
Ah. Okay. Question
Can
number
be
4.
cracked. Can be cracked into octane. What are the balance? Oh, this one isn't that hard. It says so for dodecene,
Hmm.
decene, we
Hmm.
have 12. So I'm gonna take time in this one.
Hmm. Try.
H2n plus 2. So agar 6 है C12 H2 24 plus 26 and
Hmm.
then octane
Hmm.
is again CnH2n plus 2 octane C8
Hmm.
H
Hmm.
to 16 18 and
Hmm.
we have ethene
So,
which is Cn plus H2n. Ethene is 2, so C2 plus H4. Now C12H26 gives us C8H18
hmm.
plus C2H4.
Hmm.
But then it's not balanced because here I have value of C as 12, H key is 26. On the other side, I have value of C as 8 plus 2, which is equal to 10.
To
Hydrogen's
multiply
value
this,
is 18
you need to
times.
multiply this by 2. Getting? So it can be
Uh,
balanced.
18. So, but how do I know it's 2?
How do I know it? You see now, C8 is there.
Because I'm missing 2, and if I add it to the other one, it'll be greater. So I add 2.
Yes.
Add
So 2 you
2
added means the 2 to the 4. 4. So that is 4. 4 carbon 4. So total how much is the carbon? 12. Now go for the hydrogen. Hydrogen how many are there? 18 and here is 4 to the 8. So how much it is coming? Hydrogen 26.
So, no, that's.
Hmm.
Oh, yeah.
Understood.
Yeah.
So that is you
So I was
multiply by
halfway
2.
right.
Now it's okay, complete now. If you
Yeah.
multiply by these 2, so everything is balanced now.
Yeah, I was halfway there, I think.
Okay. Can you understand or doing
Yes.
something?
No, sir, I understood.
Okay. Can I erase?
Yeah.
Okay. Key point. Key point. Can you read the key point by yourself, please? These are the key point. Can you read?
Um, Large hydrocarbon molecules can be
Hmm.
split up into smaller molecules by passing the vapors over a hot catalyst or by mixing them with steam and heating them with a very high temperature. So when mixing them with steam, that process is known as
Cracking.
hydron no
Acha,
hydration.
hydrogenation. Hmm.
Hydro hydronation.
No, hydrogenation.
Hydrogenation.
Hmm. Let us see. That is, you may be confused. See here. The,
No,
acha,
it is
hydrogen
hydration.
hydration. The reaction is called hydration. I put it wrong here. Hydrogenation means addition of hydrogen, and addition
You're
of water is
adding
called
water,
hydration.
hydration.
Hydration. So, okay, I am sorry. Here is hydration. So that is okay. Next key point.
Cracking produces saturated hydrocarbons, which are used as fuels, and unsaturated carbons, which are called alkenes.
Done. Next one, last one.
Alkenes and other unsaturated compounds containing carbon-carbon double bonds react
Hmm.
with yellow-orange bromine water, turning it colorless.
So this is what we understood till now. So can we? There is no other questions. All we did the questions,
I'm
right?
sorry.
Whatever the question were given that we already have done.
Yeah,
What shall we do next one? Can we go the chapter number 13.2?
yeah.
Okay, let us check. Very small chapter that we can finish today only. Okay, so here you see in this one what we can learning objective. What are the learning things we are going to learn here? How monomers make
Make
polymers. That is
polymer.
what. How alkenes undergo polymerization reaction. How to represent polymerization reaction by equation. These things we are going to learn. Okay. Firstly, I want to know from you, do you know anything about the polymers?
No.
Polymers you don't know. See, here I am using the term poly. Poly means what is many. Many. Mers, MERS. Mers means unit. So what is the polymers? When many small unit combined, they form the polymers. So what is that is when I am writing it when uh, many small unit
So unit is like particles?
unit means molecule unit such as ethene it can be. I will explain again. Many small unit combine combine to form large molecule. Large molecule is called polymers. Is called polymers, and the reaction is called polymerization, and reaction is called polymerization. Check. Can you understand this one definition?
Yes.
Can I read? Can
Yes.
I read? Yes.
Yes.
Okay. Now let us read out this one. Making polymers from alkene. Our heading chapter name is what? Making polymers from alkene. This is making polymers from alkene. How can you make the polymers? See, this is the monomers unit are there. Very, very small unit you can see monomers. These monomers are called ethene, right? These ethene, when you are hitting this one in the presence of catalyst, they are joining together. All together they are joining in the line, and this is forming what? Polythene. Poly means many, ethene, polythene. Polythene bag, you know, na? That is what. Similarly, these are the propene, and they are combining together. That is called polypropene. Now, you read here. You read here better to understand. The
The
fractional
fractional
distillation of
distillation of crude
read, read.
oil and cracking produces a large range of hydrocarbons. These are very important to our way of life. Products based on crude oil are all around us. It is difficult to imagine life without them. Hydrocarbons are main fuels. We use them in our transport, at home to cook and for heating. We also use them to generate electricity in oil-fired and gas-fired power stations. Then there are other chemicals made from crude oil that are used to make things ranging from cosmetics and explosives, but most important waste chemicals from crude oil is to make plastic.
So most important one is the plastic. What we are using the plastic? See here, CH2 double bond CH2 is there, and this we are taking n time. And what we are going to do, this is we are doing the polymerize. No, polymerize. I think your health is not okay.
Yeah, I'm sorry.
So it is combining CH2, CH2. This is the one unit. This is the one unit, and it is going to be n time, right? It means this is the CH2. Here we can write CH2, then CH2. This is one unit. Then again it is going to be CH2, CH2 one unit. Then CH2, CH2. This is going to keep on going. So here I am writing that is n. One unit is this one, right?
So this is
So that is,
methane.
no, this is
Methane.
ethene, na? Ethene. This is ethene. Double bond is there, na?
I think
Ethene.
there is no
So that is n number of time is there, na? So this is called what? Polythene,
polythene.
or that is also known as plastic. Can you read this one, or should I read?
So I'm
Plastic.
just writing that 1 second.
Acha, okay. You are writing. That is, you are great. So that is, you are in Singapore.
No, I'm in Dubai.
Okay. Dubai. Dubai. One more student is with me. His name is what is Arav? I think, or what? Arav. No, Arav is Singapore. Dubai. Who is in Dubai? Which student? Okay. One girl is there in Dubai. I forgot her name. She was studying earlier IB chemistry. I forgot her name.
Sir, I'm done. Should I read?
You read, please.
Plastics are made up of huge molecules, made from a lot of small molecules joined together. We call the small molecules monomers. We call the huge
Okay,
molecule.
wait. So they are saying plastics are made up of huge molecules made of lots of small molecules. What is a small molecule?
Monomers.
Joined together, we call small molecules monomers. Okay, and we call huge molecules polymers. Mono means one, poly means many. Engineers can make different type of plastic which can have very different properties by using the different monomers. So these things you can easily understand. Now read this one, please. Ethene.
Ethene C2H4
Hmm.
is the smallest unsaturated hydrocarbon molecule. It can be turned into a polymer known as or
Hmm.
polyethylene or polythene. Polyethylene is a really useful plastic as it is easy to shape, strong, and transparent, unlike manufacturers adding coloring material to it.
Hmm.
Plastic carrier bags, some drinks
Hmm.
bottles, dustbins, washing
Hmm.
up bowls, and cling films are examples of uses of polythene.
Okay, this one.
Propene C3H6 is another alkene. Engineers can also make polymers with propene as the monomers. The polymer formed is called polypropene. It forms a
Hmm.
very strong, tough plastic. Manufacturers use this to make things including carpets, milk crates, and ropes.
Okay, so this is, you got to know, na? Small molecule are called, that is small molecules are
Monomers.
called monomers. Somewhere they are there, na? Somewhere we already reached this one, monomers, and when they polymerize they form the polymers.
Polymers.
Now how monomers join together? Okay, let us see how monomers. See, one ethene 2 ethene and 3 ethene. So this bond is splitting this side and this side. This bond is splitting this side and this side. This bond is splitting this side and this side. So see, here one bond is free, and between two carbon there is new bond. Again between two carbon there is new bond, and this side again it is going to be free. So when
Sir,
alkene
but
molecules
then
join,
single bonds are formed, not double bonds.
so they will convert na. Otherwise valency will be 5 6 na. 5 cannot be there, so double bond will convert into single bond. So when
But
alkene molecule join together, the double bond between the carbon atom in each molecule open up, it replaced by single bond as thousand of molecules joined together. This is called polymerization. That is what the double bond is split up. Here you see one bond is splitting, going this side and half going this side, half going this side, half going this side,
okay.
half then join. So half is here free, half is here free, and remaining are here joined. Can you check this one?
Yeah.
You can write like this also. I explained earlier. So N molecule you are taking, and N is becoming here long chain polymers, where N is large number. Can you understand this one?
Yeah.
Can I erase?
Yes, sir.
Okay. Modeling polymerization activity. Use monomer model kit to show how ethene molecule polymerize to form polythene. Make sure you can see how the equations shown above represent the polymerization reaction. You have models. Describe what happened to the bond in the reaction. So double bond is converting into single bond. Think of model of demonstration polymerization of ethene using the people in your class and monomer. Then evaluate the ideas over group. It is very simple. Study tips. Double bond in ethene, alkene, make it much more reactive than the ethane. Double bond is more reactive than ethane. Summary question. Please read the summary question number 1.
Define a monomer and a polymer. Monomers are small molecules,
Hmm.
and polymers are many. So polymers are those small molecules joined up to create a
Join
big
together. That is large molecule.
large molecule.
B number.
What is the name for the reaction between a large number of monomers? Name of polymerization.
Okay. Next one.
Write an equation to represent formation of polythene from
Hmm.
ethene.
Hmm.
Ethene is C2H4.
Hmm.
Um,
So like that, how can we write? Here we can write like that. According to book, if you are writing, that is also much better. So here is the hydrogen, downside hydrogen. Here is the hydrogen. Hydrogen, you can take n number of molecule. Then let it polymerize. If it is polymerized, double bond converting into the single bond.
single
Here it
bond.
is single bond. And here is the bond. And this bond is how many times? Here we are representing
And
n. So this is right the equation to represent. That is okay. State 2 usage of polythene. What is the use of polythene? Making plastic bag,
making
making
plastic
toys,
bags. And
making chairs, and so many. Question number 2.
why is ethane the smallest possible alkene molecule, whereas methane? Because this ethane is unsaturated, and we only use alkenes
Hmm.
which are unsaturated to make polymers.
Okay, thank you. So next one, question number third A.
Draw the displayed formula of a propene molecule showing all its
All its bond. So propene. Prop means how many carbon? 3 carbon, right?
three.
And somewhere will be the double bond because En is there, na? So one place will be the double bond. And remaining other places will be the single bond. Hydrogen, hydrogen. Here is the hydrogen. Here is hydrogen. And here is hydrogen. This is called propene. Can you understand?
Yeah.
You can see the propene here is also there. Where is the propane? you can see. Acha, not mention here. They did
It's not
not give.
there.
Not there. Means you have to know by yourself. Okay, next one. State two uses of polypropylene. So that is one is to make the carpet. And
Make
what is
carpet
the
and
other use?
ropes.
Thank
Make
you.
ropes.
Explain the polymerization reaction.
In part
Explain
B,
the in part B. Part B means what is the part B? Draw
we
the
didn't
diagram
finish
of
part B.
polypropylene. So that we have done already, na? Polypropylene. Can we do? Can I tell you,
Yeah.
or you can do?
No, I
See,
don't know.
okay, I'm telling you. Let me find out the vacant page where we can write. No page at all in this book. No vacant spaces at all. Okay, I'm taking here. We can write. This is CH3 CH double bond CH2 is there, na? I am writing this molecule like different way. CH, here is CH3 double bond CH2. How many I am taking? N molecule.
And
Now this bond is one bond is going to split this one. So half will go this side and half will go this side. So this will form CH. This is the bond. Downside CH3. This is the CH2. This is. And now here is what is there is N. This is called polypropene. Polypropene. Can you please write down this one, polypropene?
yeah.
Hmm. Done.
No. One second.
Done.
Yeah.
Okay. Last. Okay,
That
that is
was the
over.
last one.
Okay. Key point you please read once. Then we will wind up the lectures.
Plastics are made
Plastic.
of polymers.
Hmm.
Polymers are large molecules made when many monomers, small reactive molecules join together. The reaction between monomers to form a polymer is called a polymerization.
So this is all about the today's class, Tarini. Thank you very much. Did you check your mail?
Yeah, I did. I
You
replied
find any?
also.
You find my message?
I didn't see the video because I didn't have Wi-Fi, but I replied to the other one.
Okay, good. Just I see here that is.
Yeah.
Okay, that is also for communication purpose. I was thinking that is to ask what chapter you are going to study. What the next class you want to study?
Can we go backwards? So, like we after we
But,
finish 13, go 11,
uh,
10, 9, like backwards.
so means
After we
wait,
finish 13,
13 is what is the 13? Let me see.
13 we're
13
doing
is
today.
this one, no?
Yeah.
The properties of polymers. Okay,
Yeah, after we finish
13.4
chapter 13, we can
use of
go
polymers,
chapter 11 and stuff.
plastic waste. Okay, then 13 point, so many are there. Okay, 14
It's
you are
okay.
saying later on you will study, na?
Yeah.
So next class we will try to finish the 13. Then you are saying that 10. 10,
No,
10
no,
or
no,
what?
no, wait 1 second. After 13, what is 14? 14 is also linked to hydrocarbons, right?
Yeah.
Okay, we'll do 14 and then after 14,
Hmm.
can we go backwards to chapter 11 and stuff?
Okay, well, let me see the 11th, what is there. 1 second.
Chapter
This circuit.
11 is rate of reaction,
Acha, exothermic,
energy
endothermic.
changes and chemical reactions.
Okay, good. Okay, no issue. So Okay, we'll see you then. Okay.
Okay, yeah. Bye,
Okay.
sweet. Thank
Bye.
you.
Bye. Bye. Take care. Take care.